നമസ്കാരം. ഹയർ സെക്കൻഡറി പരീക്ഷ എഴുതാൻ പോകുന്ന എല്ലാ കൂട്ടുകാർക്കും സ്വാഗതം. ഇന്ന് നമ്മളിവിടെ കാണാൻ പോകുന്നത് മലപ്പുറം ജില്ലാ ഹയർ സെക്കൻഡറി കെമിസ്ട്രി ടീച്ചേഴ്സ് അസോസിയേഷൻ നടത്തി വരുന്ന ഹയർ സെക്കൻഡറി മോഡൽ ഇവാലുവേഷൻ 2022 ഓക്സി കെമിസ്ട്രി 2.4 സീരീസിലെ അവസാന ക്വസ്റ്റ്യൻ പേപ്പറിൻ്റെ ഡിസ്കഷനാണ്. ഫുൾ മാർക്കിനുള്ള എല്ലാ ചാപ്റ്റേഴ്സും ഉൾപ്പെടുത്തിയ ഒരു മോഡൽ ഇവാലുവേഷൻ ടെസ്റ്റാണ്. അതിൻ്റെ ആൻസർ കീ ആണ് നമ്മളിവിടെ ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത്. എന്നാൽ അതിനു മുമ്പായി ഈ വർഷത്തെ ക്വസ്റ്റ്യൻ പാറ്റേണിൻ്റെ ഒരു ഏകദേശ ധാരണയാണ് ആദ്യമായിട്ട് നമ്മൾ അവതരിപ്പിക്കാൻ പോകുന്നത്. ഈ പ്രാവശ്യം ഫോക്കസ് ഏരിയയും നോൺ ഫോക്കസ് ഏരിയയും മിക്സ് ചെയ്ത സെപ്പറേറ്റ് സെക്ഷൻസോട് കൂടിയ ക്വസ്റ്റ്യൻ പേപ്പറാണ് നമ്മൾ പ്രതീക്ഷിക്കുന്നത്. ഇതിൽ പാർട്ട് 1 രണ്ട് രൂപത്തിൽ നമുക്ക് ഇവിടെ പ്രതിപാദിച്ചിരിക്കുന്നു. പാർട്ട് 1A-യും പാർട്ട് 1B-യും. പാർട്ട് 1A-യിൽ ഏകദേശം 1 മുതൽ 9 വരെ ചോദ്യങ്ങൾ പ്രതീക്ഷിക്കാവുന്നതാണ്. ഇതിൽ 5 ചോദ്യങ്ങളുടെ ഉത്തരം ഒരു സ്കോർ വീതമുള്ള ഫോക്കസ് ഏരിയയിൽ നിന്നുള്ള ചോദ്യങ്ങളാണ് നമ്മൾ പ്രതീക്ഷിക്കുന്നത്. പാർട്ട് 1-ലെ B സെക്ഷനിൽ 10 മുതൽ 13 വരെയുള്ള സീരീസിലായിട്ട് 4 ചോദ്യങ്ങളും ആ 4 ചോദ്യങ്ങളുടെയും ഉത്തരങ്ങളുമാണ് നമ്മൾ പ്രതീക്ഷിക്കുന്നത്. ഓരോ ചോദ്യത്തിനും നോൺ ഫോക്കസ് ഏരിയയിൽ നിന്നുള്ള ചോദ്യങ്ങൾക്കായി ഓരോ സ്കോറുമാണ് വിധിച്ചിട്ടുള്ളത്. അങ്ങനെ മൊത്തം പാർട്ട് 1-ൽ നമുക്ക് 9 ചോദ്യങ്ങൾക്കുള്ള ഉത്തരം എഴുതണം, 9 മാർക്കിന്. അതിന് നമുക്ക് 1 മുതൽ 13 വരെയുള്ള ചോദ്യങ്ങൾ പ്രതീക്ഷിക്കാം. പാർട്ട് 2-ൽ മേൽ പറഞ്ഞ പോലെ തന്നെ 2 സെക്ഷനുണ്ട്, സെക്ഷൻ എയും സെക്ഷൻ ബിയും. അതിൽ സെക്ഷൻ എയിൽ 14 മുതൽ 17 വരെ ഈ ചോദ്യങ്ങൾ ഫോക്കസ് ഏരിയയിൽ നിന്നാണ്. 2 സ്കോറാണ് ഓരോ ചോദ്യത്തിനുമുള്ളത്. അതിൽ 2 ചോദ്യങ്ങളുടെ ഉത്തരമാണ് പ്രതീക്ഷിക്കുന്നത്. സെക്ഷൻ ബി മേൽ പറഞ്ഞതുപോലെ തന്നെ നോൺ ഫോക്കസ് ഏരിയയിൽ നിന്നുള്ള 18 മുതൽ 20 വരെയുള്ള ചോദ്യങ്ങൾ. അതിന് 2 ചോദ്യങ്ങളുടെ ഉത്തരമാണ് പ്രതീക്ഷിക്കുന്നത്. സ്കോർ 2 സ്കോർ വീതമാണ്. ഇനി പാർട്ട് 3, അതിൽ സെക്ഷൻ എ വീണ്ടും ഫോക്കസ് ഏരിയയിൽ നിന്ന് തന്നെയായിരിക്കും. 21 മുതൽ 24 വരെയുള്ള ചോദ്യങ്ങൾക്ക് 3 മാർക്ക് വീതം. അങ്ങനെ 3 ചോദ്യങ്ങളുടെ ഉത്തരമാണ് പ്രതീക്ഷിക്കുന്നത്. അത് ഫോക്കസ് ഏരിയയിൽ നിന്നുള്ളതായിരിക്കും. പാർട്ട് 3-ൽ തന്നെ ബി സെക്ഷൻ 25 മുതൽ 27 വരെയുള്ള ചോദ്യങ്ങൾ. ഓരോ ചോദ്യത്തിനും 3 സ്കോർ, 3 മാർക്ക് വീതം 2 ചോദ്യങ്ങൾക്ക്. ഇത് നോൺ ഫോക്കസ് ഏരിയയിൽ നിന്നായിരിക്കും ചോദിക്കുക. പാർട്ട് 4 സെക്ഷൻ എ, ബി എന്നീ വിഭാഗങ്ങളിൽ ഫോക്കസ് ഏരിയയും നോൺ ഫോക്കസ് ഏരിയയും കവർ ചെയ്യുന്നു. അതിൽ 28 മുതൽ 31 വരെയുള്ളവ ഫോക്കസ് ഏരിയയിൽ നിന്നുള്ളവയായിരിക്കും. 3 ചോദ്യങ്ങളുടെ ഉത്തരമാണ് പ്രതീക്ഷിക്കുന്നത്. ഓരോ ചോദ്യത്തിനും 4 മാർക്ക് വീതമായിരിക്കും ഉണ്ടാകുക. 32, 33 ചോദ്യങ്ങൾ. 2 ചോദ്യങ്ങൾക്ക് 2 ഉത്തരവുമാണ് പ്രതീക്ഷിക്കുന്നത്. അപ്പോൾ 2 ഉത്തരങ്ങൾ അതിൽ പ്രതീക്ഷിക്കുന്നുണ്ട്. ഓരോ ചോദ്യത്തിനും ഓരോന്ന് വീതം. ഇതിൽ ചോയ്സ് കാണുന്നില്ല. ഓരോന്നിനും 4 മാർക്ക് വീതം നോൺ ഫോക്കസ് ഏരിയയിൽ നിന്നാണ്. പാർട്ട് 5 ഒരു സെക്ഷനെ നമ്മൾ പ്രതീക്ഷിക്കുന്നുള്ളൂ. ആ ഒരു സെക്ഷന് 34 മുതൽ 36 വരെയുള്ള ചോദ്യങ്ങളാണ് ഉണ്ടാവുക. ഈ ചോദ്യങ്ങളെല്ലാം ഫോക്കസ് ഏരിയയിൽ നിന്നായിരിക്കുമെന്നാണ് പറയപ്പെടുന്നത്. ഇതിൽ 2 ചോദ്യങ്ങളുടെ ഉത്തരമാണ് പ്രതീക്ഷിക്കുന്നത്. ഓരോ ചോദ്യത്തിനും 6 മാർക്ക് വീതം. ഇങ്ങനെ നമുക്ക് മൊത്തം 60 മാർക്ക് 2 മണിക്കൂറുകൾ കൊണ്ട് എഴുതേണ്ടതായിട്ടുണ്ട്. എല്ലാവരും നന്നായി പഠിച്ച് പരീക്ഷ എഴുതാൻ വേണ്ടി ശ്രമിക്കുക. അതിനായിട്ടാണ് മലപ്പുറം ജില്ലാ കെമിസ്ട്രി ടീച്ചേഴ്സ് അസോസിയേഷൻ ഈ മോഡൽ ഇവാലുവേഷൻ സീരീസ്, ഓക്സി കെമിസ്ട്രി സീരീസ് പരീക്ഷകൾ നടത്തുന്നത്. അതിൻ്റെ അവസാന പരീക്ഷയുടെ ആൻസർ കീ, ക്വസ്റ്റ്യൻ വിത്ത് ആൻസർ കീ ആണ് നമ്മളിവിടെ പറയാൻ പോകുന്നത്. എല്ലാ കൂട്ടുകാരെയും ഒരിക്കൽ കൂടി സ്വാഗതം ചെയ്യുന്നു. മലപ്പുറം ജില്ലാ കെമിസ്ട്രി ടീച്ചേഴ്സ് അസോസിയേഷൻ ഹയർ സെക്കൻഡറി മോഡൽ ഇവാലുവേഷൻ 2022 ആൻസർ കീ ഡിസ്കഷൻ. The first part, section A, you have to answer any 5 questions from 1 to 9. Each question carries 1 score, and all these questions from 1 to 9, that is from focus area. The first question, name the monomer of nylon 6. The monomer of nylon 6 is caprolactam. അതിൻ്റെ സ്ട്രക്ചറാണ് നമ്മളിവിടെ കൊടുത്തിരിക്കുന്നത്. And its polymer is nylon 6. Second question, which of the following is a polysaccharide? We have four choices: maltose, sucrose, fructose, and cellulose. Maltose is a disaccharide, sucrose is a disaccharide, fructose is a monosaccharide, cellulose, which is a polysaccharide like starch. So the answer is D. And the third question, Williamson synthesis is an important method of synthesis of dash. Williamson synthesis is a method of synthesis of ethers, and the synthesis is like this: alkyl halides on reacting with sodium alkoxide. It can form ether with the sodium halide. An example, methyl iodide with the sodium methoxide, and it can provide ethyl methyl ether, which is an unsymmetrical ether. Anyhow, this particular synthesis is known as Williamson synthesis. The order of reactivity of alkyl halide in SN1 reaction, the tertiary, secondary, primary, secondary, tertiary, likewise. We have two nucleophile substitution reactions, SN1 and SN2. In SN1 reaction, the order is tertiary, secondary, and primary. So tertiary, secondary, and primary. So that is the answer. The fifth question, what is oleum? Oleum is an oxoacid of sulfur, and we have different choices: pyrosulfuric acid, sulfuric acid, sulfurous acid, and peroxodisulfuric acid. Let us see what are these. Pyrosulfuric acid is this one, having an SOS bond, which is an oxoacid. There is a sulfur OH bond, Then sulfuric acid is there, sulfurous acid is there, H2SO3, and peroxodisulfuric acid. Here a peroxide linkage is there. That is why it is peroxodisulfuric acid. So what is our choice? Oleum is H2S2O7. That is disulfuric acid. And in this one, it is pyrosulfuric acid. So we have pyrosulfuric acid, sulfuric acid, sulfurous acid, and peroxodisulfuric acid. And pyrosulfuric acid is the oleum. And the sixth one, which of the following is lyophobic colloid? We have different types of colloids based on the interaction of the solute and solvent, dispersive phase and dispersion medium, like starch in water, which is lyophilic, gum in water is lyophilic, soap in water is lyophilic, but gold salt, which is lyophobic colloid. And seventh one, what is the unit of rate constant for zero order reaction? We have different orders of reactions and having different units. And we have a general equation for getting the units: mole raised to 1 minus n, liter raised to n minus 1, and second raised to minus 1, where n is the order. So if you put the value of n in this general equation, you will get the unit of the rate constant for zero order, first order, second order, likewise. Here for zero order, n is 0. So mole 1 minus 0, liter 0 minus 1, second raised to minus 1. So naturally the unit of zero order reaction is mole liter raised to minus 1, second raised to minus 1. Right. Then to the eighth one. The eighth question is: limiting molar conductivity of an electrolyte is obtained by adding the limiting molar conductivities of cations and anions of the electrolyte. This is a statement and this is a definition of a law. Name the law. This particular law is known as Colrash's law of independent migration of ions. Where we know the limiting molar conductivity, lambda infinity, is equal to the lambda infinity of cations plus lambda infinity of anions. That is the equivalent conductance of at infinite dilution is equal to conductivity of cation plus conductivity of anions. Ninth question, calculate the number of tetrahedral voids if magnesium crystal contains n number of atoms. We know we have different types of voids in crystal structures, like tetrahedral voids, octahedral voids, etc. If whether it is magnesium or not, if it contains n number of atoms, we have n number of octahedral voids and 2n number of number of atoms for tetrahedral voids. So we have 2n tetrahedral voids and n octahedral voids, right? So what will be the total number of voids? That is n plus 2n, that is 3n, like this. So such voids surrounded by the spheres, that is octahedral voids, and if it is like a tetrahedral structure, it is tetrahedral void. So the number of tetrahedral voids is equal to 2n. And next we are going to see the section B of part 1. Answer any 4 questions from 10 to 13. And each question carries 1 score, and these questions are from non-focus area. Which of these is temperature dependent? And we have different concentration terms like molarity, molality, mole fraction, parts per million, etc. We have different concentration terms, but here we have only 4 choices: molarity, molality, mole fraction, and parts per million. Out of this, which is temperature dependent? See, in the group A, we classified this into group A and group B. The volume related is actually temperature dependent. Volume related is as temperature varies, its volume varies. So group A having the volume related, temperature dependent, and group B the amount related, mass related, and the temperature independent. And our question is temperature dependent. That means that having the concentration terms having this volume related equation, percentage by volume, percentage weight by volume, molarity, normality, like that. All these having certain volume terms in it. In group B, it is percentage by weight, mole fraction, molality, parts per million. All these are mass related or the amount related. So our answer is molarity. What is the basicity of H3PO3? H3PO3. We have different choices, 1, 2, 3, 4, etc. Normally, it is numbers. So what is this basicity? Basicity of a molecule is the number of acidic hydrogen atoms. To be acidic, hydrogen must be bound to highly electronegative atom, like oxygen or fluorine. In phosphoric acid, 2 hydrogen atoms are bonded to oxygen. In this structure, you can see 2 hydrogen atoms are bonded to oxygen. Hence, that become acidic. So, and that third hydrogen, which is directly bonded to phosphorus, and that is not acidic hydrogen. So we have only 2 hydrogen atoms which are acidic. Hence, the basicity of phosphoric acid is 2. Here you can see that in H3PO3, that is another oxide acid of phosphorus. H3PO3, that is oxide acid of phosphorus. We have 2 OH which is connected to the hydrogen. So only this hydrogen can be given out on dissociation as H plus ion, so that is acidic. In H3PO2 we have only 1 hydrogen like that, so its basicity is 1. So we have different examples for that, right? Then 12th question. CH3CH2CH2Br is an alkyl halide with alcoholic potassium hydroxide, right? And this is an elimination reaction. It is known as beta elimination reaction. And the elimination leads to an unsaturated compound propene. And the mechanism of the reaction is given in this slide, where the OH that takes part in this particular reaction, and that leads to an unsaturated product propene, right? And the 13th question, and this will be the last question in this section. Dash plus Grignard reagent, CH3MgBr, gives CH3CH2O-MgBr. Then hydrolysis gives an alcohol, ethanol. So what is that? The reactant that reacts with this Grignard reagent, that is formaldehyde, that is an aldehyde, and that is formaldehyde. The formaldehyde that reacts with the Grignard reagent, which gives a primary alcohol like CH3CH2OH. So the answer is HCHO, that is formaldehyde. Then to the section A of part 2. We have to answer 2 questions from 14 to 17 series, and each question carries 2 marks, 2 scores, and all these questions are from focus area. What are ideal solutions? And what type of deviation is shown by a mixture of chloroform and acetone? Give reason. An ideal solution is a solution which obeys Raoult's law over all concentrations, over the entire concentration. Solutions that obey Raoult's law. We know what is Raoult's law, where the vapor pressure of the solution containing a non-volatile solute at a given temperature is equal to the product of vapor pressure of the pure solvent and its mole fraction in the solution. That is PA, or pressure, vapor pressure of the solution that contains a non-volatile solute, that is PE is equal to P0A chi A. Okay, so in general we can say that on adding a non-volatile solute to a solvent, the vapor pressure of the solution always lowered. So that is Raoult's law. And the second part of the question, what type of deviation shown by chloroform acetone? Chloroform acetone shows a negative deviation. Chloroform can form hydrogen bond with acetone. It can form hydrogen bonds with acetone. So the vapor pressure decreases. Right. So that shows a negative deviation. So the solute solvent interaction increases and hence vapor pressure decreases. As the solute solvent interaction increases, it gives lesser amount of vapors, so its vapor pressure decreases. And we have three different graphs. The first graph is for the ideal solution that obeys the Raoult's law, and the second is for a positive deviation mixture, and third one is a graph for negative deviation mixture. Okay, that is from the Raoult's laws. So negative deviation that shows a decrease in vapor pressure. 15th question, write two factors influencing rate of a reaction. Actually, the concentration and temperatures are the important factors that influence the rate of a reaction. And that can be explained with the help of an equation, that is Arrhenius equation. Arrhenius equation is very simple. The rate constant is equal to A e raised to minus EA by RT. A e raised to minus EA by RT. It is a logarithmic equation. The rate constant is K here. A is a pre-exponential factor, that is a constant, also known as Arrhenius constant. E is the base of natural logarithms, and the power of that one is minus EA by RT. EA is the activation energy, R is the gas constant, and temperature, T is the temperature in Kelvin. It's not degree but Kelvin. Log K is equal to, we can rewrite this equation as logarithmic form. Log K is equal to log A minus EA by 2.303 RT. Minus EA by 2.303 RT. 16th question, name the property of colloid involved in the construction of ultramicroscope. Actually, ultramicroscope that works with the principle of Tyndall effect. What is Tyndall effect? Tyndall effect is the scattering of light by the colloidal particles. If you are passing a light through the colloidal particle, the light is scattered by the colloidal particle, and that can be observed using a microscope is known as ultramicroscope. So the principle behind that one is Tyndall effect. What are the conditions to be satisfied to exhibit Tyndall effect? So we have defined what is Tyndall effect. It is the scattering of light by the colloidal particles. And the conditions to be satisfied are this one. The main conditions are the diameter of the dispersed phase is not much smaller than the wavelength of the light used. The diameter, the size of that particle is not much smaller. Not much too smaller than the wavelength. It is big enough to scatter the light. And the second one is the refractive indices of the dispersed phase and medium differ greatly in magnitude. Otherwise, the solution cannot be visible separately. So we have to see that solution separately. Right. So the diameter of the dispersed particle is not much smaller than the wavelength of the light used. The refractive indices differ greatly. Size of the particle generally between 10 raised to minus 11 and 10 raised to minus 9 meter in diameter size. Okay, the difference in refractive indices, we can say that the two phase and the medium in the colloidal solution can be seen separately in the system, hence we can say their refractive indices are different. 17th question, name the monomer of natural rubber. Natural rubber is polyisoprene, so its monomer is isoprene. 2-methyl 1,3-butadiene. Its polymer is natural rubber. Vulcanization is a process which is used to improve the elasticity of rubber. What is vulcanization? Vulcanization means it is a process of converting natural rubber or like rubbers to more strong and elastic. So we are changing the physical properties. So that is the process of changing the physical properties of that to desired level. Natural rubber is mixed with about 3 to 5% of sulfur and heated to about 100 to 150 degrees Celsius. 3 to 5%, 100 to 150. It is to cross-link the different chains of natural rubber by sulfur linkages, poly or disulfidic linkages, mono, di or polysulfidic linkages. Here you can see the disulfidic linkage. Thus you can change the property. And that process is known as vulcanization. You can see the reaction like this one as structure wise. To the second part, section B, answer any two questions from 18 to 20. And each carries 2 marks, and these are from non-focus area. Name the method used for removing gangue from sulfide ores. How to remove gangue from sulfide ores? Usually we are employing the froth flotation method because sulfide ores are lighter than the impurities. So you can use froth flotation and explain the above method. It is a very simple method. In this process, we can use a suspension of the powdered or that made with water. And to this, we have to add certain collectors, oil like pine oil, like etc. And froth stabilizers like aniline, etc. are added, and agitate these thoroughly and pass air through this in order to get the froth or foam. And the froth formed carries these mineral particles because it is lighter, so that float over that particular solution, and the froth is skimmed off, washed and dry to get the concentrated ore particles. So it is a very simple process. So you have to remember all this one. First the powdered ore mixed with water, then pine oil, then stabilizer like aniline, agitate, then pass air through it, collect the froth and dry it. That is all. 19th question. Why is water a liquid and H2S a gas? Water a liquid and H2S a gas. It is a simple question where you know water H2O which can connect with each other through hydrogen bonding, intermolecular hydrogen bonding. But it is not possible in the case of hydrogen sulfide because in our definition for hydrogen bonding, it consists of only hydrogen, then nitrogen, oxygen and fluorine. Nitrogen, oxygen and fluorine are the electronegative of one molecule, then it connects with the hydrogen of another molecule. There is no sulfur, so it is not seen in hydrogen sulfide. So hydrogen sulfide exists as gas, though oxygen and sulfur are in the same group, they are neighbors. Second one, PCl3 fumes in moisture, give reason. PCl3 fumes in moisture, give reason. PCl3 can react with the moisture and form H3PO3 plus HCl. And that HCl is the reason behind the fuming nature of PCl3. Okay, HCl gas. That is because of this one, the fuming nature of HCl gas that gives the fuming nature for that particular reaction when PCl3 opens in moisture. And you can see two reactions in this one. Section A, benzoyl chloride with hydrogen supported by palladium barium sulfate. Hydrogen supported by palladium barium sulfate. It is a reduction process, and it is the reduction of acyl halides to aldehydes. That is Rosenman reduction. These are the reagents used in the Rosenman reduction. Hydrogen, palladium supported by barium sulfate. And the second reaction, reduction of an aldehyde with zinc amalgam and HCl. Zinc amalgam and HCl is the region for Clemmensen reduction. Both are reductions. But the Rosenman reduction is for acyl halides to aldehydes, but Clemmensen reduction is aldehydes to an alkane. It's a complete reduction. That is Clemmensen. We reduce that particular group completely. So CH3CHO to CH3CH3. It is to an alkane, right? And that reaction is Clemmensen. And to the part 3, section A, you have to answer any 3 questions from 21 to 24, and each question carries 3 scores, and all these are from focus area. The first question of this section, 21st question, among the following, which metal is extracted from bauxite? Extracted from bauxite. It is naturally aluminium. Okay. So you have to know the different ores of various metals, right? Explain the method for refining zirconium. We have a method that is vapor phase refining method for the refining of zirconium, that is Van Arkel method. Another method is there for vapor phase refining, that is Mons process, which is for nickel. Here it is zirconium. Zirconium and nickel both are by vapor phase refining. Zirconium, and that particular method is known as Van Arkel method. Here the metal first react with or heat with iodine in an evacuated vessel. The metal give metal iodide, which is volatile, zirconium iodide, ZrI4. And this metal iodide is collected elsewhere. Impurities have to be removed meanwhile. And the metal iodide is decomposed electrolytically by using tungsten filament at high temperature, or by heating to about 1800 Kelvin, higher temperature than this zirconium and iodine reaction. This zirconium iodide gets decomposed to zirconium and iodine back. That is a reversible process like that. The pure metal thus deposited on the filament. Thus you can purify, refine zirconium. Right. One more question from this SN1 reaction. What is SN1 reaction? SN1, it is a nucleophilic substitution reaction. It is nucleophilic substitution unimolecular reaction. That is SN1. Substitution nucleophilic unimolecular. How will you prepare chlorobenzene from diazonium chloride? Before that, SN1, we have seen the order of that particular reaction, tertiary, secondary, primary, like that. Actually, that involves two steps, we can say. First, the breaking of the carbon halogen, loss of a leaving group. Thus, it can form a cation, and then the new nucleophile attached with that one, that is a nucleophilic attack, and we will get the product. So, the reaction that depends on the stability of that cation, that is SN1. How will you prepare chlorobenzene from benzene diazonium chloride? Benzene diazonium chloride, which is treated with the HCl in presence of cuprous chloride to get chlorobenzene. This particular reaction is known as Sandmeyer's reaction. This reaction is known as Sandmeyer's reaction. Right. Then next is match the following. Two columns are given. And the first column, certain compounds are there like equanyl, furazine, penicillin, aspirin, phenol solution, ranitidine, etc. And column B having the corresponding nature of that one. Let us match these. Equanyl is a tranquilizer. You know, a tranquilizer, it is a neurologically acute drug. Equanyl is a tranquilizer. Furazine is an antiseptic. It is an antiseptic. We have antiseptics and disinfectants. Antiseptics can be used in open wounds. So, furazine is such a type medicine. You can say drug. Penicillin is an antibiotic. It is an antibiotic. It is used against the growth or killing of bacteria. Aspirin, which is an analgesic. 0.2% of phenol solution, which is a disinfectant. A disinfectant that cannot be used on open wounds, open ulcers, but can be used on inanimated objects like floors or bathrooms, etc. Ranitidine, which is used against acidity, that is an antacid. It is an antacid. So this is the answer. Next question, name the ore of potassium dichromate from which it is prepared. What is the ore of potassium dichromate? It is chromite ore, FeCr2O4, chromite ore. K2Cr2, give one example for the oxidizing properties of potassium dichromate. Write the balanced equation. It is a very good oxidizing agent in all conditions, neutral, acidic or basic. Right. And here we have an acidic medium. It can oxidize the iodide ions to iodine. Iodide ions to iodine. Right. Then the section B of the part 3, we have questions from 25 to 27. Out of these 3 questions, you have to write 2 answers. Answers for 2 questions. Each question carries 3 marks from non-focus area. What is the product obtained when phenol is treated with concentrated nitric acid? It is a product that is 2,4,6-trinitrophenol. 2,4,6-trinitrophenol. It is also known as picric acid. Distinctly acidic in nature. Write the structure and IUPAC name of the product. We have given that one, 2,4,6-trinitrophenol. Ethanol and propane have comparable molar masses, but their boiling points differ widely. Which of them having higher boiling points? How we can substantiate that answer? Ethanol and we have propane. You know, ethanol having a functional group OH. This OH can link with the other OH through hydrogen bonding, intermolecular hydrogen bonding. So it is possible there in ethanol, intermolecular hydrogen bonding is possible. But there is no hydrogen bonding in other type of molecules like propane or dimethyl ether, etc. So ethyl alcohol has higher boiling point because of the hydrogen bonding. And next question, give one example each for an aliphatic aldehyde and an aromatic aldehyde containing some atoms, carbon atoms, 7 carbon atoms. One example each for aliphatic and aromatic. 7 carbon atoms are there, you know. So aromatic aldehyde normally, you know, benzene ring with one CHO, that is benzaldehyde. Aliphatic aldehyde, you can write it directly with the 7 atoms in a chain, and one carbon atom here, one carbon atom is that CHO, that is heptanol. Second part, give one reaction in which the above aldehydes differ. One is aromatic and another one is aliphatic. So here we are using Felling's solution to distinguish this aromatic and aliphatic. What is a Felling solution? Actually, a Fehling solution that consists of two solutions, Fehling A and Fehling B. We have to mix this at the time of reaction. Fehling A is copper sulfate solution, Fehling B is sodium potassium tartrate solution. It is also known as Rochelle salt solution. So whenever you need, these two solutions has to mix with each other, and these two solutions are mixed in equal amounts just before the test. On heating an aldehyde with the mixture, that is Fehling's reagent, that is Fehling's A plus B. If you get a reddish brown precipitate, actually that reddish brown precipitate is copper oxide. Copper oxide having the color reddish brown. Aldehydes are oxidized to corresponding carboxylate ion. That is why copper 2 plus ion oxidized to reddish brown copper oxide. Reduced to reddish brown copper oxide. Aldehyde simultaneously oxidized to carboxylate anion. But aromatic aldehyde does not respond to this test. This is for aliphatic. So it is for heptanol, it is positive for heptanol but negative for benzaldehyde. Aromatic aldehydes do not respond this particular test. Only aliphatic aldehyde have to be that can oxidize to the carboxylate ion, not the aromatic aldehydes. The 27th, which vitamin is responsible for blood clotting? Different vitamins are there, A, B, D, E, K, C. Different vitamins are there. Out of this, we have two classes: water soluble and fat soluble. Okay, and A, D, E, K vitamins are fat soluble vitamins, attack vitamins. This vitamin K, which is responsible for the clotting of blood, vitamin K. Right. Then describe the primary and secondary structure of proteins. Actually, we have different structures like primary, secondary, tertiary, quaternary structures, and we have only 2 marks for this. You have to write primary and secondary structures only. But still, just know what are the structures of proteins. Primary structures are the sequence of the chain of amino acids. Sequence of the amino acids in the chain. There is a particular sequence of amino acids in the chain. Actually, that determines the property of that protein. One of the properties, biological properties. Then, to the secondary protein structure, this protein can fold. It can fold. Local folding of the polypeptide chain into helix or sheets. Alpha helix, beta pleated-like structures. That is the secondary. That is the folding of the primary structure. And to the tertiary structure, it can three-dimensionally fold. The secondary structure can three-dimensionally fold. Three-dimensional folding pattern of a protein due to the side chain interactions. There are certain interactions. Because of these interactions, it can fold three-dimensionally. That is the tertiary structure. And to the quaternary structure, where protein consists of more than one polypeptide chains are there. Different polypeptide chains are there. They combinedly fold into a three-dimensional manner. So primary, secondary, tertiary and quaternary, actually all these structures having its own biological actions. Right. So these are the basic one is primary, that is the sequence. Then folding, folding, folding. Right. Section A of the 4th part. Answer any 3 questions from 28 to 31 and each carries 4 marks. All these questions are from the focus area. What do you mean by colligative properties? These are for solutions. These are the properties that depend only on the number, not on the nature. Depend only on the number of solute particles, not on the nature of solute particles. So number, not nature. That are the points to be remembered. For determining the molecular mass of polymers, osmotic pressure method is preferred over the other colligative properties. Why? For polymers like macromolecules, osmotic pressure method is good compared with the other properties. Why? Because polymers are poor. They have poor solubility. They are less soluble. They can dissolve only to a little extent, and so their solution is very dilute in nature. The magnitude of osmotic pressure is large even for very dilute solution, but it is not in the case of other colligative properties. Hence, osmotic pressure measurement is very much suitable for the determination of their molar masses, because a very little solubility is enough for getting the result. Similarly, other molecules like biomolecules etc. also to be used to determine the molar mass with this particular property, because this can take place at room temperature. We don't need to change the temperature, so we can maintain the biological properties. Third one, the intravenous injections are for intravenous injections only solutions with osmotic pressure equal to that of 0.9% solution, sodium chloride solution is used by 0.9% sodium chloride, that is the normal saline solution, and is having the same osmotic pressure as that of blood. Same osmotic pressure means isotonic. So our blood cells are isotonic with 0.9 mass by volume sodium chloride solution. Hence osmosis does not occur if we place the blood cells in this solution or we take injections with this 0.9% sodium chloride solution. Otherwise, the blood cells may destroy. If the blood cells are placed in sodium chloride with higher or lower, the osmosis takes place, blood cells may shrink or swell. Hence, it is very suitable that the 0.9% sodium chloride is used in these intravenous injections. 29. Name the most important oxo acid of nitrogen. What is an oxo acid? We know that particular element, in this case it is nitrogen, it is connected with an oxygen that having an hydrogen. So it is connected to an OH group actually. We have different types of oxo acids for nitrogen. Hyponitrous is there, that is H2N2O2. It is a dimer of HNO. Nitrous acid is there, that is HNO2. Nitric acid is there, that is HNO3. Pernitric acid is there, HNO4. So HNO, HNO2, HNO3, HNO4. Simply. HNO is a dimer. And the most important oxo acid among this one is nitric acid, that is HNO3. How will you prepare this oxo acid on large scale? That is by Oswald process. Large scale preparation of HNO3, nitric acid. For that we are using ammonia, NH3. It oxidizes in presence of certain catalysts like palladium, rhodium, go at a high temperature and high pressure. It gives NO, and this NO reversibly reacts with the oxygen to form NO2, and this NO2 with water gives HNO3. This is a three-step process, Oswald process, industrial process for the preparation of nitric acid. And what are the allotropic forms of phosphorus? Here we have yellow phosphorus is there, or white phosphorus is there, red phosphorus is there, black phosphorus is there. So various allotropic forms of phosphorus. And the next question, the compound CrNH3 4 times Cl2 Br is a coordination compound. That we can understand because it is enclosed in square brackets etc. And that is an indication that it is a coordination compound simply. Identify the central metal ion of the above compound. Central metal ion, that means the metal ion present inside the square bracket, coordination sphere, coordination entity, that is Cr3 plus. And the name the ligands in it, NH3 and Cl minus. Br minus is not ligand, it is counter ion. And the coordination number of this one is 6 because Cr connected with 4 NH3 and 2 Cl2, 2 Cl. So its coordination number, that means it is the number of nearest neighbors, that is around the chromium metal ion, that is 6. Write the UPSC name. Tetraamine dichlorido chromium 3 bromide. So certain rules are there, you have to follow that rules while naming. First the ligands, the number of ligands, then the metal, then the counter ion. In the case of positive negative, like this one, if the sphere is positive, you can write the name of the metal as such, like chromium, like that. And the name of NH3, it is amine, A-M-M-I-N-E. And Cl minus is not chloro, it is chlorido. So that certain rules are there, you have to remember that one. And the 31st question, what do you mean by a first order reaction? What is a first order reaction? First order reaction means its order is 1. Or the reaction in which the rate of the reaction is directly proportional to the concentration of reactant. Everybody can say first order reaction where the order is 1. But the definition for this one is the concentration, the rate of the reaction is directly proportional to the concentration of the reactant. R is equal to K into R. K is a rate constant. What is the relation between rate constant and half-life period of a first order reaction? Half-life period of a first order reaction. First order reaction, the rate constant is 0.693 by T half. T half is the half-life period. That is why its unit is second raised to minus 1. Because there is only second time, that is by time. Half-life period of a first order reaction is 20 seconds. It's a problem. How much time will it take to complete 90% of the reaction? You have to go through the question 2 or 3 times. Then you will get the answer easily. Half-life T half. First order K is equal to 0.693 by T half. T half is 20 seconds. So 0.693 by 20. That is the K, rate constant. How much time will it take to complete 90% of the reaction? Complete 90% of the reaction. So what is the final concentration? It is in percentage, so initial concentration is 100%. And it is to complete 90%. That now the remaining quantity is only 10%. So initially it is 100%, now it is 10%. So for a first order reaction, the equation for the rate constant is K is equal to 2.303 by T log R0 by R. R0 is the initial concentration, R is the final concentration. And T is the time taken to get that concentration R. So 2.303 by T. So we have to find out T. We already found out the value K. So you can substitute T is equal to 2.303 by K log R0 by R. Simply substitute all this, you will get T is equal to 66.46 seconds. Next, the fourth part, section B, answer any 2 questions from 32 to 33. Each question carries 4 scores, non-focus area questions. Arsenal-sulfate AS2S3 salt particles are negatively charged. It's a statement. Then what happens when barium chloride is added to the salt? So when barium chloride is added to the negatively charged AS2S3 salt, coagulation or precipitation may occur. Coagulation or precipitation may occur by the oppositely charged particles in that salt, by adding barium chloride. How do you account the above process? That is the explanation. Negatively charged AS2S3 is neutralized by adding the oppositely charged by it is neutralized by barium 2 plus ion. Neutralized by barium 2 plus ion. How do you account for the above process? That is this answer. Neutralization by oppositely charged electrolytes adding to that colloidal salt. What is the effect of adding aluminum chloride instead of barium chloride? Barium chloride, the formula is BaCl2, where barium is 2 plus. Aluminum chloride is AlCl3, where aluminum is Al3 plus. So according to Hardy-Schultz rule, higher the oxidation state, greater will be the coagulating power. So in this case, Al3 plus can coagulate more than Ba2 plus. That is according to Hardy-Schultz rule. 33. A list of lanthanide ions are given. La3 plus, E4 plus, Yb2 plus, Yb yttrium, Lu3 plus, and their atomic numbers are given. Give the number of unpaired electrons in each ion. So you have to write the electronic configuration for this one. We have the different electronic configurations for La, lanthanum 3 plus, cerium 4 plus, ytterbium 2 plus, lutetium 3 plus. Give the number of unpaired electrons. Identify the ion with paramagnetic meaning having unpaired electrons. Identify the ion which is colorless. That means all the electrons are paired. Here we have the different configurations of all these series. Scandium, ytterbium, yttrium, lanthanum, cerium, like that. So the valential configuration for La3 plus is 4f0. 4f0. So the number of unpaired electrons 0. Cerium 4 plus, that is 4f0, where the unpaired electron is 0. Yttrium, ytterbium here, Yb. Ytterbium, yes. It is 4 of 14, ytterbium 2 plus is 4 of 14, so the number of unpaired electrons is 0. And Lu3 plus is 4 of 14, again it is 0. So all these having the unpaired electrons are 0. They are diamantic. All these are diamantic, all are paired. All are colorless because they do not contain any unpaired electrons, partially filled orbitals. Then to the fifth part, There is only one section. 2 questions from 34 to 36 and each carries 6 scores. And all these questions are from focus area. So you have to answer any 2 questions from 34 to 36. 34. Sodium chloride has FCC structure. Calculate the number of NaCl units in unicellular sodium chloride. This is the unicellular sodium chloride. In sodium chloride, the chloride ions arranged in FCC manner. Chloride ions. Here it is the open circle. And the Na plus ions, that is the blackened circle. And they occupied the octahedral voids. So the number of chloride ions in a unit cell is equal to 4. Since FCC it is 4. 1 plus 3. And number of sodium ions is equal to 4. Since all the octahedral voids are occupied by the atoms or ions. So number of sodium chloride is 4. It is very simple. This particular structure is made up of chloride ions. It is FCC. So there are the number of particles 4. Chloride ions 4. The number of particles for the octahedral voids 4. Because the number of particles is equal to octahedral voids. And all the octahedral voids are occupied by the sodium ions. So how many sodium ions? 4. So 4 sodium ions, 4 chloride ions, total 4 sodium chloride units. When pure sodium chloride crystal is heated in an atmosphere of sodium vapors, it turns yellow, give reason. Here we can see the first one, sodium chloride crystal with alternate sodium ions and chloride ions. When it heats in presence of sodium vapors, some of the chloride ions, that is in green color, they came out from the crystal lattice by leaving an electron there, or they came out as Cl- and combined with the sodium in the vapor phase and can form sodium chloride by leaving an electron, and that electron goes back to that particular vacant space from where it came. And these electrons are responsible for the color. So these centers are known as color centers, also known as F centers, Farben centers. Farben means color. And sodium chloride is heated in an atmosphere of sodium vapor. Some sodium atoms are deposited at the surface of the crystal. Some chloride ions diffuse to the surface of the crystal and combine with the sodium to form sodium chloride. And the electron so formed diffuses into the crystal and occupies that vacancy, anion vacancy. And these are responsible for the color. And the next question is, how will you account the following properties, paramagnetic and ferromagnetic? Paramagnetic, having unpaired electron, ferromagnetic also having unpaired electrons, but paramagnetic substances are weakly attracted by the external magnetic field. They are weakly attracted by the external magnetic field. Paramagnetism is due to the presence of one or more unpaired electrons. But they are temporary. Whenever you remove the external magnetic field, it can lose that magnetic property. But ferromagnetic substances are strongly attracted by the external magnetic field. And all these unpaired electrons, their vectors are aligned that particular direction, and that alignment become permanent. So that can be permanently magnetized. The magnetic moments are aligned in one direction and they become permanent, have a permanent magnetic moment. That is the difference between these two. 35th question, write the equation showing the relationship between conductivity and molar conductivity. Write the equation. Molar conductivity lambda m, 1000 kappa by m. 1000 kappa by m. That is the relation between the molar conductivity and conductivity. Lambda m is molar conductivity, kappa is the conductivity, m is the molarity. What is meant by limiting molar conductivity? Molar conductivity at infinite dilution or zero concentration is the limiting molar conductivity. And explain the change of conductivity and molar conductivity of a solution with the dilution, decreasing concentration. You can decrease the concentration up to zero concentration or infinite dilution. That infinite dilution is limiting molar conductivity. For strong and weak electrolytes, conductivity always decreases with the dilution. Conductivity decreases with the dilution because as dilution increases, concentration decreases. That is the meaning. Number of ions per unit volume decreases because we are increasing the volume, thus decreasing the concentration. Hence, the conductivity decreases. That means the number of ions per unit volume decreases, conductivity decreases. Molar conductivity increases molar conductivity increases with the dilution for strong and weak, because increase in the ionic mobility for strong electrolytes and increase in the degree of dissociation for weak electrolytes. Because if you are increasing the dilution, the dissociation also increases. Hence, the number of current carrying particles increases. So that is the reason behind weak electrolytes. Increase in the molar conductivity behind weak electrolytes. What is the reaction taking place at standard hydrogen electrode when it is connected with a silver electrode to form galvanic sand? Where the standard hydrogen electrode, oxidation occurs and reduction occurs at silver. So hydrogen that get oxidized to hydrogen plus ions and silver ions that get reduced to silver. So oxidation occurs at SHE. Name the reagents used in Hofmann-bromamide reaction. Hofmann-bromamide reaction is a reaction in which an amide is treated with bromine. All these are there in that particular name itself. Bromine amide. So it is amide is treated with bromine in an aqueous or ethanolic solution of sodium hydroxide. It is an alkaline solution. Degradation occurs. So actually the name is Hofmann-bromamide degradation reaction. So degradation of this amide occurs and a carbon atom removed from that amide, and it leads to the formation of an amine, primary amine. So it is for the preparation of a primary amine. This reaction involves loss of a carbon, hence it is a degradation. It is known as Hofmann-bromamide degradation reaction. Here we have that reaction: acetamide with bromine and sodium hydroxide, methanamine. Acetamide having 2 carbon atoms, but methanamine having only 1 carbon atom, and it is a primary amine. Propanamide having 3 carbon atoms, and after the reaction we have only 2 carbon atoms that become methanamide. Right. That is the significance of that particular reaction, we can say. Right. Then what is Innsberg reagent? One of the significance is we can decrease the number of carbon atoms in the amide. Other one, it is used to produce primary amines. Right. Okay. Then next one. What is Innsberg reagent and how will you distinguish primary, secondary, tertiary using Innsberg reagent? Innsberg reagent is benzene sulfonyl chloride. Where primary amine react with the benzene sulfonyl chloride to form soluble product, soluble in aqueous sodium hydroxide. A product which is soluble in aqueous sodium hydroxide. Secondary amine which can react with the benzene sulfonyl chloride and can give a product, but it is insoluble in sodium hydroxide solution. Whereas tertiary amine, there is no reaction with the benzene sulfonyl chloride. That is Innsberg test for primary, secondary, tertiary amines. And the next question for this one is, how will you distinguish all this? So we have distinguished that the primary amine forms a compound which dissolves in alkali. Secondary amine forms a compound which does not dissolve in alkali. Tertiary amine that does not react with the Innsberg reagent. So these are about this test paper, and we have covered all the questions, and we have seen 36 questions with some sub questions. So altogether we covered about 100 questions and its answers with other points also. So you please do your examination well, do your best. All the best. Thank you.